Okay, so yes, infinite series can be pretty tough, but the good news is that there are a lot of us here that can help you get through this. So I actually asked them, how can I help? And they asked me to go over some examples of the direct comparison tests. So let's do that. We use the direct comparison test with series of positive terms. And then if we have two series such that the general term for the first one is always less or equal to the general term for the second one, then we can compare them. For example, if the series with an, so the smaller of the two series, diverges to infinity, then the series that is larger of the two series, so the series with bn, has to also diverge. It also has to go to infinity. And similarly, if the larger of the two series, so the series with bn's, converges and it has a finite sum, then the smaller of the two series, the series with an, also has to converge and it also has a finite sum. Let's see some examples. Suppose you want to see if this infinite series diverges or converges. So to use the direct comparison test on that series, I have to find some other series that I'm going to be able to compare to this one and that I know that it converges or diverges. And that one, the general term, 1 over n squared plus 1, reminds me of 1 over n squared if I forget about the plus 1. And that series, the sum of 1 over n squared, converges because of the p-test. Next, what I have to do is find a comparison between the two general terms, an inequality between them. And since this one has a larger denominator, then 1 over n squared plus 1 is always less or equal to 1 over n squared. So that tells me that the infinite series I'm interested in is the smaller of the two, and I know that the larger series converges because of the p-test. Therefore, by the direct comparison test, I have that the sum of 1 over n squared plus 1 converges. Let's look at another example that is a little bit more complicated. To find a different series to compare it to, what I do is forget about smaller order terms in numerator and denominator. So in particular, in the denominator, n squared is much larger than n or 1, so n over that quantity is approximately n divided by n squared, which is equal to 1 over n. And then what I try to do is to find an inequality between the two. Now, this denominator is smaller than n squared, so this fraction is always bigger or equal to n divided by n squared, which is 1 over n. Therefore, the series we're interested in is always bigger or equal to the series of 1 over n. But the infinite series of 1 over n diverges because it is the harmonic series. And therefore, by the comparison test, the series I'm interested in is bigger or equal to the harmonic series which diverges, so the series I'm interested in also diverges.